Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. The term attack surface is often used as though it means the same thing as the internet-facing network, the list of known vulnerabilities, or the set of systems owned by the technology team. Those ideas overlap, but none of them captures the full concept. An organization can reduce exposed servers and still leave weak account recovery, unmanaged cloud services, trusted vendors, or persuasive social requests available to an attacker. That misunderstanding affects real decisions because security teams may protect what they can easily scan while missing the paths that people, data, and business processes actually depend on. The practical question is not only which systems are online, it is where an unauthorized person, compromised account, malicious program, or unintended action could enter the environment, influence what happens inside it, or extract information from it. By the end of this episode, you will be able to explain what belongs to an attack surface, what does not, and how that understanding should guide security priorities.
An attack surface is the complete set of places where an environment can be reached, manipulated, or used to expose information. It includes technical points such as accounts, devices, applications, network services, cloud resources, and data interfaces. But it also includes relationships and human processes that can be influenced. The surface exists because the organization must allow legitimate interaction. Employees need accounts, customers need applications, administrators need remote access, systems need to exchange data, and vendors may need trusted connections. Each useful interaction creates conditions that must be governed. The main distinction to remember is that an attack surface describes the available opportunities for interaction, not proof that every opportunity contains a weakness. A vulnerability is a specific weakness, while an attack vector is a method used to pursue access or influence. Risk reflects the possible harm when relevant threats, weaknesses, exposure, and business consequences come together. These terms are often confused because they describe connected parts of the same security problem. Accounts form one of the most important parts of an attack surface because identity is how many modern systems decide who may act. User accounts, administrator accounts, service accounts, application identities, access tokens, recovery methods, and inactive credentials can all create reachable paths. The concern is not limited to passwords. Enrollment procedures, help desk verification, session management, authorization rules, and the ability to reset or delegate access also shape the identity surface. A reused password is a vulnerability, but the account itself is part of the attack surface because it is a point through which the environment accepts identity claims. Multi-factor authentication, MFA, can reduce the chance that a stolen password alone will succeed, but it does not remove the account or every way the account may be abused. Security decisions, therefore, need to consider how identities are created, used, monitored, reviewed, and retired. An account inventory that ignores non-human identities will describe only part of the surface. Devices add another layer because every connected endpoint can send, receive, store, or process information. Workstations, mobile phones, servers, network equipment, printers, operational technology, and Internet of Things, IoT devices, may all expose services or trust relationships. A device does not have to be reachable directly from the public internet to matter. It may be reachable through an internal network, a remote management tool, a wireless connection, a synchronized account, or a trusted application. Unsupported software, unnecessary services, and weak configuration are vulnerabilities, while the device and its reachable functions belong to the attack surface. Device ownership also matters. Personally owned equipment, temporary systems, laboratory equipment, and forgotten hardware may escape normal management, even though they still connect to organizational data or accounts. Effective protection depends on knowing which devices exist, what they can reach, who is responsible for them, and whether their exposure is necessary. A device that cannot be inventoried cannot be governed with confidence. Applications contribute to the attack surface through every function they provide and every connection they accept. Login pages, administrative consoles, file uploads, search fields, payment functions, integration points, update mechanisms, and application programming interfaces, API, all create ways for data and instructions to enter or leave. The application surface is not limited to visible screens. Background services, mobile application connections, development interfaces, test environments, and machine-to-machine communication may be more important than the public interface. A programming error or insecure configuration may create a vulnerability, but the broader surface includes the complete set of exposed functions, roles, permissions, and data flows. Security teams need to ask not only whether an application is patched, but also whether each function must be available to each audience. An unused administrative endpoint can add exposure without adding business value. Reducing unnecessary functionality, restricting access, validating input, and monitoring abnormal behavior address different parts of the application surface, rather than solving the whole problem with one control. Cloud services expand the attack surface by making computing, storage, identity, and software available through distributed platforms and management interfaces. A cloud resource can be created quickly, connected to other services, shared with external users, or exposed through a configuration change. Software as a Service, SaaS platforms may hold sensitive messages, documents, customer records, or business workflows, even when the organization operates no server for them. Management consoles, automation credentials, public storage settings, synchronization features, and cross-account trust all become part of the surface. The cloud provider protects some layers, but the customer still controls many choices about identity, configuration, data sharing, and use. This is why cloud security cannot be reduced to asking whether the provider is secure. The practical question is which responsibilities remain with the organization and where its decisions create exposure. A forgotten cloud project, an overly broad sharing link, or an unreviewed integration can remain reachable long after its original purpose has ended. Vendors and other external relationships can also enlarge the attack surface because trust often crosses organizational boundaries. A supplier may receive account access, exchange files, manage infrastructure, process data, provide software updates, or connect through an integration. Those relationships create legitimate paths that an attacker may try to misuse, especially if the vendor has weaker controls or if the organization grants more access than the service requires. The vendor itself is not automatically a vulnerability, and using outside services is not automatically unsafe. The surface comes from the permissions, connections, data exchanges, dependencies, and support processes that link the two environments. Contract terms and assessments matter, but technical access still needs to be limited, monitored, and removed when it is no longer needed. Third-party risk becomes easier to understand when the relationship is mapped as part of the attack surface. The organization may outsource a service, but it does not outsource the consequence of unauthorized access, data exposure, or operational disruption.
We will pause briefly for a transparent message from the host. This episode is brought to you by the Bare Metal Cyber Academy. The Academy provides a place for people who want to continue developing practical cybersecurity knowledge through clear, structured education. Topics such as identity, cloud exposure, applications, and third-party access become easier to manage when the underlying concepts are explained in a connected way. You can visit baremetalcyber.com to explore the Academy and see the learning opportunities currently available. There are no promises of instant expertise or guaranteed career results, only an invitation to keep building useful knowledge with careful instruction. Now, let's return to the attack surface and examine the role people and everyday processes play in it.
People are part of the attack surface because systems depend on human judgment, communication, and authority. Employees, contractors, administrators, support staff, executives, and customers may receive requests, approve changes, share information, recover accounts, or override normal procedures. An attacker may try to influence those actions through deception, urgency, impersonation, or misuse of trusted context. The human being is not a flaw to be blamed, and the answer is not to treat every person as a vulnerability. The relevant surface consists of the decisions and communication channels through which people can affect access, data, money, or operations. Training can help, but training alone cannot compensate for a process that allows one message to authorize a sensitive change without verification. Stronger design uses clear procedures, independent confirmation, limited authority, and technical controls that make unsafe actions harder. The human attack surface is therefore both a security awareness issue and a process design issue.
An attack surface also has external and internal dimensions. The external surface includes points that can be reached from outside the organization, such as public applications, remote access services, email channels, exposed cloud resources, and vendor connections. The internal surface includes pathways available after someone gains a foothold or when a trusted user misuses access. Internal file shares, administrative tools, flat network relationships, excessive privileges, and broadly available data can allow influence to spread beyond the original point of entry. Focusing only on the perimeter assumes that preventing initial access is sufficient, but modern environments require legitimate remote access, cloud interaction, and constant data exchange. The better approach is to limit what each identity and system can reach even after access has been granted. Segmentation, least privilege, and monitoring help reduce the useful pathways inside the environment. The attack surface is therefore not a single outer boundary. It is a collection of interaction points and trust relationships distributed throughout the organization.
Attack surface, vulnerability, threat, and risk should not be used as interchangeable labels. The attack surface tells you where interaction is possible. A vulnerability tells you what weakness may make that interaction unsafe. A threat describes a person, action, event, or condition capable of causing harm, while an attack vector describes the route or technique used to pursue that harm. Risk describes the possibility and consequence of a harmful outcome when those elements connect to something the organization values. This distinction changes the response. Removing an unused service reduces the attack surface. Patching a software flaw addresses a vulnerability. Blocking a known malicious source may disrupt a particular threat activity. Backups may reduce the consequence of some incidents without preventing the initial access. A control can affect more than one part of the relationship, but the team should still understand what it is intended to change. Clear labels make it easier to select controls, assign ownership, and explain why one problem should be addressed before another. The attack surface changes whenever the environment changes. New employees receive accounts, devices connect, applications are updated, cloud resources are created, vendors are added, and data begins flowing through new integrations. Temporary access may become permanent through neglect, and a development service may become exposed without appearing in the original inventory. This means attack surface management is not a one-time diagram or annual scanning exercise. It is the continuing work of discovering assets and relationships, validating ownership, understanding exposure, and comparing what exists with what the organization intended to exist. Automated discovery can reveal public services and cloud resources, but tools do not automatically understand business purpose or acceptable access. Human review is still needed to decide whether a connection is necessary, whether a permission is appropriate, and who must correct it. A current attack surface is a moving operational picture, not a static list stored for audit purposes.
Reducing an attack surface does not mean eliminating every account, device, application, cloud service, vendor, or communication channel. Organizations need these capabilities to operate, and security that blocks all interaction would also block the mission. The goal is to remove unnecessary exposure, narrow legitimate access, strengthen the remaining paths, and watch for misuse. An unused service can be disabled. An administrative interface can be restricted to approved management networks. An account can receive only the permissions required for its role. A vendor connection can be time-limited and monitored. Sensitive data can be separated from systems that do not need it. These actions reduce opportunity without pretending that useful technology can become unreachable. Monitoring remains necessary because a small, well-managed surface can still be attacked and preventive controls can fail. Good attack surface decisions balance operational value against exposure.
Then apply layers of protection where the interaction must remain available.
A practical way to examine an attack surface is to start with what the organization values and trace every legitimate path that can affect it. Identify the accounts that can reach the asset, the devices that connect to it, the applications and interfaces that process its data, the cloud services that store or synchronize it, and the vendors or people who can influence its operation. For each path, ask whether it is necessary, who owns it, what level of access it provides, and how misuse would be detected. Then separate surface from weakness. The existence of a login page is exposure, while weak authentication is a vulnerability. A vendor integration is exposure, while excessive permissions are a vulnerability. Use that distinction to choose an action. Remove the path, restrict it, strengthen it, monitor it, or accept it with documented reasoning. Repeating this review after meaningful change makes the result useful for decisions rather than merely descriptive.
An attack surface is all the reachable or influenceable places through which an unauthorized party or harmful action could enter an environment, change what happens within it, or extract information from it. It includes more than public servers. Accounts, devices, applications, cloud services, vendors, internal trust relationships, communication channels, and human approval processes can all contribute. The surface is not identical to a vulnerability because an available point of interaction may be well protected, and it is not identical to risk because business consequence and likelihood still have to be evaluated. Understanding the surface gives security work a clearer starting point. It shows where exposure exists, where ownership is unclear, where access can be reduced, and where monitoring must be strongest. The practical discipline is to keep the map current, remove paths that no longer serve a purpose, limit the paths that remain, and connect each control to the specific opportunity for access or influence that it is meant to reduce.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.